plot the control chart and then you plot it here. See any point above it, right? Of course, at this point, unless you calculate every value, you can know lah, you can see. But then I just let you know that there's no point falling outside the upper control limits. You confirm yourself. There's no point falling above it. So all the points are okay here. No out of control point. No out of control point. Okay. So there's no need to remove any line. Okay. And then can you go ahead to calculate, see whether the R&R meet 20%? Now you can do. I think 3 minutes you get it done. Okay, can you? Just do it. You only need to calculate RPT lah, that's all. RPT, what is this? Right. And then sigma R&R is equal to RPT. Right, sigma RPT. And after that, PT ratio. And what is this? Is it greater than 0.2? Can you fill up the space? Yeah? That's all. Now you can talk to each other, no issue. Yeah, because this is more like a group project.
Sigma RPT में we have sigma RPT, we have sigma RPD. Yeah, then become the triangle. upload this on YouTube. I upload this on YouTube so you can see. No, I don't want. I'm uploading it to YouTube. Can make it private, right? No, public. Can make it public. Okay. This is strong. I'm not on the video. Save my memory. Oh, God.
So does it fail or pass? 8.9%, right? Answer is 8.9%. Got it? 8.9. So it's much better than 20%. Okay, let us do it. This because there's only one. Normally we get R bar plus the sum of the 2 or 3, right? But since there's only one operator, this automatically equal to R bar. Automatically, because there's only one. So it's R bar divided by D2 straight away. So this is equal to 257, right? And then n equal to 3, right? Because there are 3 trials. N equal to 3, what is the number? This is 100, 100, 1.693, so it's 59, yeah, 59 angstrom, right? And then this is also 59, right? It's upper spec minus lower spec, we already have it, right? Given here, 4,000, right? 4,000. So 6 sigma divided by 4,000, right? So this is equal to 0.089. So 8.9%. 8.9 is less than 20%, so it's acceptable. Got it? Sigma. 6 multiplied by 59. 6 multiplied by 59 divided by 4,000. Right? Got it? This is so it gives you 8.9%. Yeah?
Oh, the table shift like crazy, yeah.
Cannot? What's that? Sigma. This because sigma RPD is equal to 0. It's equal to 0. Yeah. So it's equal to 0, right? Yeah. Your question is because originally is this equal to square root of right? Square of this plus square of RPD. RPT, right? But this is equal to 0, right? Equal to 0 doesn't exist. Any square and square root, and it is automatically equal. Can, huh? It's okay, huh? So, if it is automated, then it's quite straightforward, right? Automated, it will reduce the values of sigma R and R because RPD doesn't come into the picture. Okay, so more likely to be acceptable, which makes sense, lah. Which makes sense. Okay, can, huh? So we proceed. Okay, huh? So let's proceed to the next stage. Of course, it got to be acceptable. If not acceptable, then the problem will stop there. Right? It got to be acceptable. So if things are acceptable, then the next stage is the control chart. Okay, the interferometer is okay, no problem. Which means that the numbers are collected, the data collected makes sense, right? At least meet our requirement. So then the the customers, potential customer, will go through the test, right? And then to collect all this all the data over 5 working days, right? Working days. And then I tabulate the measurements, which is given here. Next slide. And this is the data for the control charts. Notice that over 5 days, so each day 5 wafer, right? 5 wafer, and then morning and afternoon shift, and then 5 wafer, and then the actual measurements. Then measure at different locations. Notice that this location. So measure here, and then put it down here, right? And then X bar and R. So control chart. This is X bar. This is R bar. Right? So with X bar and R bar, we can plot the control charts. So data, is that clear? Okay, huh? Data is clear, huh? So then we plot the control chart, and after that see whether X bar chart and R chart is in control or not. Okay, huh? And I give you this one. I think we don't spend time. I give you the answer because once you got that, then you can calculate. So I give you the answer, and then you check for yourself. The center line you can put down straight away for X bar chart is 9932.5. Center line for R chart. Center line for R chart is 874.9. You can put it down straight away. Center X chart is 9932.53. $874.90, right? And then this one, it will be 9932. Remember, X bar plus A2 R bar. R bar is 874.90, right? And this one will be minus A2. This, right? A2 you can for n equal to 3 lah. So you check for yourself. Is 10872. I'm sorry, this is a bit dark for me because there's no light here, so I cannot see. This equal to 10827.6, and this one is 9037.5. 9037.5. Okay, and then this is D4 R bar. D4 R bar. And this is D3 R bar. Right? 2252. 2252.0. 2252.0. And this is a negative value, so it's 0. Okay. So this, no issue, that's quite straightforward. And then with the control limit, you can plot the, of course I didn't give you the exact number, so you cannot plot, you can only calculate the control limit, but then the plot is given here. This is the X bar chart, this R chart. Can you take a look? So what you need to do this is the upper control limit. Okay, the center line upper control limit. What you have just calculated. So I didn't make it better because this is really the actual plots by the engineers. So I just sort of stick to the original study. This is the center line. This is upper control limit. This is lower control limit. Okay, upper control limit. So is it in control? Look like in control, right? And then the 50 points you plotted here. Okay, huh? Okay, huh? And R charts, can you plot the center line? 2251 is given there, upper control limit. Right, 2251. 51 or 52 doesn't matter. And then you need to 875. 875, can you plot 875 somewhere there? 875. Somewhere here, huh? Somewhere here. Actually, if you be very precise, it's somewhere here. Okay? 875. Okay, that's the controlled R charts. R chart, the variation seems to be less than the X bar charts. Okay, right. So then this is control charts. Control chart. Then the next step is if you assume it's in control, then we can go ahead to use method 2 to calculate the PCA and see whether it meets 1.33 or not. Okay. But very often it's good to check whether X close to normal or not. Right. So with this set of data here, we can do an MPP. MPP, normal probability plot. And normal probability plot is given later. This is normal probability plots. And then this is the X. Okay? So these two plots, what you got here and here, right, is based on the data set given here. So 50 multiplied by 3, 150 points here. Okay? We will interpret this point later because they have important implications. Okay? Important implication. I'll mention that later. Then let's assume that it's in control. And we can continue to calculate CPK, right? Right? Can you calculate the CPK? See whether it's meet 1.33. What you need to because here is a process average, you know already. Average is 993. Let's forget about the decimal place, 9933. Process standard deviations is R bar divided by D2. Right, R bar divided by D2. So R bar is 875 divided by D2. Can you calculate this 5 minutes? Then see whether greater than 1.33. Okay, can you do that?